Steady state exercise is when the body is working at a steady state. This means that lactic acid is removed at the same speed that it is produced. Here are two examples of steady state exercise. We have water aerobics and running on a treadmill. When we exercise, our heart rate increases. Once the heart has reached the demand of the exercise, the heart rate will level out. Stroke volume will also increase in venous return. The increased volume of blood has an effect of stretching the cardiac muscle beyond normal. The stretching makes the heart beat more forcibly, therefore pumping more blood out. This is known as Starling's law. As a result of steady state exercise, the blood pressure will increase. This will cause the systolic pressure to increase, but there will be only a small change in the diastolic pressure. When we exercise, our body needs to cool down. This is where thermoregulation occurs. Our blood vessel will dilate and more blood will be able to pump out to the surface of the skin and to the working muscle to cool it down. During steady state exercise, our breathing rate increases to meet the demand of the exercise to remove carbon dioxide and provide the body with oxygen. There is an increase in tidal volume as the body needs more oxygen, therefore you are taking more breaths. The diagram shows the oxygen dissociation curve. Oxygen reacts with hemoglobin to create oxyhemoglobin. This is temporary and can be reversed. The binding of oxygen to hemoglobin is dependent on partial pressure of oxygen. In high concentration of changes in pH level and carbon dioxide can shift the curve to the right or left. This is known as the Bohr effect. High level of carbon dioxide causes the acidity to increase, shifting the curve to the right, releasing more oxygen to the tissues. In the lungs, there is a low level of carbon dioxide which shifts the curve to the left, enhancing the oxygen uptake. Temperature also has an effect on the curve. When the temperature increases, the curve shifts to the right, and when the temperature decreases, the curve shifts to the left. When we exercise, the rate of our nervous transmission also increases as the muscles warm up. The heat increases the speed of transmission. As our body warms up, our muscles also warms up and becomes flexible. There is a greater stretch without tearing fibers in the muscle. The aerobic system is responsible for producing most of the energy supplied to the body. It is slow to produce but highly productive. Aerobic glycolysis is when glucose is broken down in the presence of oxygen. It is broken into pyruvate. Due to the oxygen being present, this enters a series of reactions. The Krebs cycle is when pyruvate combines with coenzyme to form acetyl, producing ATP, hydrogen, and carbon dioxide. Electron transport chain is when hydrogen atoms, which form the Krebs cycle, enters the chain, which is passed along and combine with oxygen to form more ATP. This is a slow process and therefore good for steady, low-intensity exercise such as running. This all takes place in the mitochondria. This is where energy is produced. The fold in the mitochondria is called the cristae. This fold gives it a large surface area to produce more ATP. Another change to the cardiovascular system is the cardiac output. An increase in heart rate and stroke volume will lead to an initial increase in cardiac output. During exercise, more blood is required to supply energy to the working muscles. Blood flow to organs is reduced by the constriction of blood vessel. Blood flow to the muscle is increased by the increasing flow of blood by dilation of blood vessels. Changes to the capillaries improve the body's ability to deliver oxygen and nutrients to the working muscle and to remove carbon dioxide. The blood pressure would also increase. The dilation of blood vessels supplying working muscle acts to reduce blood pressure. Immediately after we exercise, there is a fall in systolic pressure as the muscular pump is no longer pumping blood from the muscle to the heart. This can lead to fainting and dizziness as not enough blood is being pumped to the brain. All of these effects occur during exercise so that the body is supplied with oxygen and carbon dioxide is removed. This benefits the body as we can enjoy exercise for longer. The process by which glucose is broken down is known as glycolysis. Two ATP are used to fuel glycolysis. and 4 ATPs are created, so that the body gains 2 ATP for muscular contractions. The breakdown of glucose creates the substance pyruvate. Because it is anaerobic and there is not enough oxygen present to break down the pyruvic acid turns into lactic acid. Information on oxygen dissociation curve. An increase in temperature takes away the bond between oxygen and hemoglobin, which decreases the concentration of oxyhemoglobin. The curve shifts to the right as a result of this. When the temperature decreases, the curve shifts to the left. This is because the heat has been taken away from the lungs and to the working muscles. Information on neuromuscular system. As a result of steady state exercise, muscle pliability increases. This could be beneficial to someone doing sport as they could prevent injury and improve their performance. An example of reaction time would be that a goalkeeper would practice taking penalty shots before a game so that he can increase his reaction time for when the game begins. This would also increase his muscle pliability so that he can move faster during the game. Another effect of the cardiovascular system is that oxygen is being taken to the working muscles. As we exercise and our body gets warmer, blood is taken from our body to our surface of the skin to cool us down.